Okay, welcome to part two of the BA series I'm doing for the Tampa chapter of the IIBA. I want to thank Cliff and everyone on the board for making this happen. So last week we talked about a framework I have for doing business analysis, and it's based on my experience doing simulation in a lot of different contexts for quite a long time in a number of industries in almost every role. So without going into detail on that, last week we talked about all the different steps in the framework just briefly. And then we talked in detail about how they fit together. And this week we'll talk about the steps in detail. So what we have is project planning to open things up. Intended use is the what you're gonna use your project or product or process improvement for. Then the assumption shows basically what you don't know, what you do know, what your scope is, things like that. And then the conceptual model is your current understanding of the as is state of the system, if there is one, if you're not starting from scratch. Then we get into data, then requirements. That's a huge thing, requirements management for BAs. After that is design, which is it's what we're gonna build. Then the implementation is actually building it, then test and acceptance, then closing it out. So if we want to simplify it down, we have really only 6 steps plus data: figuring out or identifying the problem, finding out what's going on, figuring out what we need to do, figuring out what we need to do in detail, then actually implementing it and then testing it. So I've got these color keys. For those of you who missed last week, there are a lot of different engagement structures. Like in traditional waterfall, we just do these 6 phases in order. In Agile and Scrum, we do the first 3 cyclically. So there might be one group identifying requirements, putting them in a backlog, and another group going ahead and pulling items off the backlog and then doing the back half of the process. Hybrid is a mix of the two, where you have an overall list of requirements in design and you do the implementation and low-level design and tests cyclically within that. And then there were some more contexts. If you're going to improve a current process, um, you more or less do it like waterfall with your discovery and data collection embedded in the conceptual model. If you're doing a simulation not as the end goal, but as part of the design to help you design your project and maybe implement it, that's a separate sub-project within the larger overall project. And if you're starting a new project from scratch, the conceptual model is actually embedded in the design because there is no initial system to build a conceptual model of. So we start with project planning, which is just traditional project management techniques. You want to consider the context in which you're going to work. This is when you do the charter, build the team, work out the communication plan, and it's bookended by a project closeout step at the end, which we won't talk more about much. The intended use defines the customer's goals for what the new product is going to be. It's basically expressed in terms of business value. So what you're trying to, when you list these goals, you're trying to identify what questions the solution is trying to answer and what decisions you're using it to help you make. That's always the point, right? And the outputs that are generated to support those decisions. All right, as far as assumptions goes, here's where you do risk analysis, and then you figure out what to include and not include. So this is how you help define the scope, and also when you have to assume values if you don't have things, and if you can't get data at all, or if the impact of a given effect or component of the working system doesn't need to be considered in the solution. For example, when I built nuclear power plant simulator, they did piping and instrumentation drawings for every system in the plant. Well, the goal of a training simulator is to model only what you can see that affects anything that might show up on a control panel in the control room. And there are a lot of systems and sample ports and other things that you don't need to pay attention to. And so when people would do this phase of the project, they would highlight the elements of the drawings in a highlighter pen or marker that shows what we paid attention to and modeled and what we ignored. I have it listed after before conceptual model, but it really happens before, during, and after. The two, because you can't really do all of this until you know what's going on, to know what to include and not include. You can think of this like an equation where you figure out what things are going to change, so you make terms drop out. This is a form of the first law of thermodynamics, where you have the heat transfer is equal to the change in internal energy and the change in kinetic energy and the change in potential energy due to gravity and the amount of work done by the system. Early in our thermo course, as a probably sophomore mechanical engineer, is doing a ton of word problems that ask you different ways of manipulating this equation and similar ones. For example, you also have for internal energy, things that do and don't change temperature and so on. So that's basically the way I think about this. For the conceptual model, you start with the as is state, again, if there is one. If there's not, you work backwards from the desired outcomes to figure out what you need to get there. You map everything out and document and collect the data for everything that goes on. It's not a specific kind of drawing, but you represent that using any communication method that gets you and the customer on the same page. And customers in this case can be internal or external. So you iteratively review your work and your findings with your customers until you both agree that your understanding is complete and correct. So last week I had this customer feedback cycle. So it goes through these 6 phases, but in each one, what you're doing is iterating, documenting, discussing, and reviewing to make sure you're on the same page through every phase. And then you go forward to the next one. And what I just described is going through this loop in the conceptual model. If you find something was missed or needs to be changed in a previous phase, you go back and do that. Another thing I pointed out in the first session is that super formal or nitpicky definitions of Scrum, Kanban, Scrum Mod, Safe, whatever, they're mostly beside the point. I don't know if any of you had the chance to check out the video of one of the guys who helped write the Agile Manifesto, but he talked in 2015 about how what you're really doing is working with your customer, figuring out whether you're doing it right, and then adjusting. And that's all this is. By the way, anytime you see orange in here, that's a link to a video, a blog post, or other further information. This presentation is hosted on my website as a web page. You can go there. I'll link to it on the meetup page. So the other thing about the conceptual model is this is where BAs learn what they don't know. If they don't already come with a lot of expertise in the area that they're investigating. So how you learn things is subject matter expert interviews, observation, guided tours, and there are a lot of ways to do it. Any way you can learn is valid. So when I started in my career as an engineer, I brought everything I knew about mechanical engineering, thermodynamics, fluid mechanics, computer programming, and so on. But that was just the beginning, just enough to get me in the door. So this is a link to Liam Neeson's speech in Taken, where he talks to the bad guys. It's awesome. So some domains require super specialized knowledge. If you're going to help Albert Einstein write a simulation of nuclear particle physics, you probably, like I might be good at computers and simulation and programming or whatever, but I know nothing about the dual wave particle nature of the pi meson. So I get the experts, the subject matter experts, to tell me what's going on so I understand it. This requires a good personality in communication, and you have to show respect to and interest in those you're talking with. So the process of learning what your customers are doing, if you don't already know, is domain knowledge acquisition. And those links there take you to a number of writings I've done on that subject. So the data is about the nouns and verbs within the system, and you're identifying where you're gonna get data from. And then you're also gonna get the adjectives and adverbs which describe how the system actually operates, how much, how many, that kind of thing. So you map all that in the conceptual model. If you've done that right, the conceptual model gives you an idea of all the data you need. And you have to support everything with data if you can find it. If you can't, you have to make stuff up. That may require expert judgment, and it may require circling back once you get closer to the end to adjust some of or all of your assumptions. You have to validate the data for a number of different qualities. Most of all, can you get it? So you start off doing an abstract identification of the data, and then you get more detailed as you work through the process. That last bit, let's talk about this again. Here's how we deal with the different kinds of data throughout the process. It's not necessarily this cut and dry like that aspect of data management goes in that phase, but it's a rough guide. And I covered this last time. I'll try to make it brief here. So discovery is when you find out what the nouns and verbs are in the system and where your data is going to come from. Data collection is when you get the operating data, the statistical data, and more of your nouns and verbs about how the system works. So first of all, you find out what's going on, and then you find out how it's going on. The governing parameters are really about how the system is controlled. There are many different kinds of them. They're really embedded in the system, somewhat in the design, but mostly in the implementation. Some of these things are part of the overall scope of what BAs do, and some of them are the control variables the programmers and software engineers put in on their own for their controls to implement the vision the team is coming up with. And of course, you have generated output data, and that's what the goal of the system is. So requirements describe the abstract form of the to-be state. This is a big part of what we're trying to accomplish. So you have functional requirements that describe what the system does, and non-functional requirements, all the ilities, and there are many, many more of those potentially than there are listed. And then you have your definition of done, and your acceptability criteria are part of the requirements. Design, by contrast, is the to-be state in a more concrete form. So requirements is abstract, it's what we need in general. Design is how we're gonna provide it concretely. So it's how we're gonna do it, what resources we're gonna need. Also, maintenance and governance should be thought of at this stage. So it's designed for maintainability. It's more about the solution than the engagement. And this is an important distinction. Everything I've talked about so far is really how to run an engagement. and it's not the details of how you actually build a solution. This is more meta. At some point in the future, I will go into a little more of the solution aspect of the work of BAs starting next week. So again, this is the 2B's theme. The implementation is where the work is actually carried out based on what you said you were gonna build in the design. It also includes deployment depending on how you think about things. Or you can think about deployment, delivery, handover, and training as a separate phase out of testing. But in general, it's all part of implementation. So testing. There are two things we test. Verification is testing of how the system works, how usable it is, and that the outputs are generated accurately based on the inputs and the calculations you perform. Those things are most able to be automated. Unit tests are an example of that, but there are user interface test tools that can automate that process. There's a lot going on there. So outputs and fitness for purpose evaluations are actually validation. And that basically points toward finding out whether you're solving the actual problem. So again, verification is, does the system I built works? Validation is, does the system I built, now that it works, actually solve the intended problem? Validation results can be subjective or objective, and very often require expert judgment. So specialized SMEs may do a lot of these phases. For example, implementers would be software people, database people, graphics artists, machine learning, all those specialists that the BA may not be. But you have to be able to work together. In any case, provisions for testing should be built in from the beginning, and everyone should understand every aspect of the entire process. Acceptance is about meeting the criteria for acceptability or the definition of done. It also includes delivery and handover and all the stuff that comes along with the solution. And the customer, again, whether internal or external, can either accept the solution fully or not accept it at all, or partially accept it with limitations, after which you may or may not get to continue working. So the closeout bookends the planning phase ongoing projects may never have an effective close. They just go on forever. That's kind of a continuous integration, continuous deployment, or CI/CD context. But work done for third parties usually ends at some point. So remember, we have an ongoing iterative process for doing all the work. We keep track of it using this monstrosity that I talked about next week that links every item you identify throughout the process, forwards and backwards. If you have any questions, feel free to ask. It's in the presentation and slides that I put together last time. So, how does any of this compare to what's in this big orange honker right here? And there are a lot of things the BABOK covers, but mostly my framework, as I've described it here in detail, maps to the knowledge areas, which is the basic flow of how things get done. I'll touch on items in the other areas in future presentations. So if we map these 6 knowledge areas, those are across the top. And then we map my framework phases down here. You'll find X's in the grid where there's a really strong match and there's a lesser match. For example, in planning, so planning is planning, but you have to, you have to basically plan for every phase. So at the beginning, you have to provide for it and be aware of all the things you're gonna do. So there are smaller, darker, less emphasized X's for every phase in that column. Then the same is true for elicitation. That's when you find out what you're trying to accomplish and what you include and don't, what's important and what's not, what's going on, all the data, requirements, and implementation, also designed to some degree. Requirements is requirements. Strategy is partially about how you're gonna do implementation, but really how you're gonna do the cycle of requirements design and implementation. Requirements analysis is same thing that maps, and then solution evaluation is testing and acceptance, largely also design. So the main thing you'll notice about this is that the strongest mapping goes from the upper left to the lower right. And you have to ask why the BABOK is written that way. And it's done that way because there is BAs and project teams do so many different things that it necessarily had to be presented in a loose, general way that allows a lot of flexibility. So I'm really saying the same thing the BABOK says, except I'm saying it from the context of somebody who's done many different cycles, from the point of view of doing simulation, but not always simulation. One final thing I'll touch on, we're almost done, is that there are different kind of requirements. So the business requirements are really addressed in the intended use at a high level. The requirements, as I described them, really address what the stakeholders need. The design identifies solution requirements or it answers them, and transition requirements are handled within the implementation. So that's all I have. Let me know if you have any questions. There's a ton of other information on my website. And thanks again to the Tampa IIBA and Clem. Do you have anything to say in closing?
Hey, Bob. We're going to be posting these recordings, right? Because
Yes.
okay, I had a couple reach out that wanted a copy of the first one. So, all right, no problem. Thanks.
Yep. All right. Have a great week, everybody.